Thank you for beautiful introduction. Hello, everybody. My name is Tomaž, as Kevin beautifully put it. I'm coming from Europe, Slovenia, and feel free to, unmute yourself or ask a question any given time. I will share my screen now, so let me know if you can see the screen.
Yes, we see it.
Okay, beautiful. Okay, so since I don't see a chat window, feel free to, just, unmute yourself or something. So, because I won't be following that. Yes. So thanks again for coming. I will be, discussing about Azure Machine Learning Service today with Python. I've been around this service quite a long time, so feel free to ask literally, anything that goes with that. I've done also quite a lot of talks on this topic, so my slides are usually changing. I try to have it a little bit more interactive, less code, which doesn't mean that we cannot discuss whether you want to discuss a compute, whether you want to discuss a code. So it's really up to you. I also will be discussing something about explainability today, because this is usually a topic that is quite overlooked. So there will be also a couple of slides on that, and as well the demo. So yeah, for those who don't know me, feel free to get in touch. Otherwise, yeah, the code is usually available. I have to find the link to GitHub. Usually I have everything there, so there should also be this material for this session today. Okay, so what's on the agenda today? We'll do introduction. We'll see and check, the feature store, the data store in the cloud. We'll talk about Python SDK. We will skip R because it was deprecated, and also Microsoft ML package to go along. We'll talk about pipelines, and then we'll talk about interpretability, machine learning interpretability, and ethical AI, and also explore the packages and techniques. So this is, again, as I said, a topic that is usually, not that discussed. And this is the reason why I want to also talk about it today. Okay. So machine learning applications are available, as a service in Azure, and literally you can do any of those topics as you wish. There are quite a lot of functions available with the Python SDK. So essentially, if you want to do any of those, you are ready and free to go. So feel free to do any of those problem-solving things that you want to do. Let's just quickly talk about how does the life cycle of machine learning look like. So the first, we have to define a problem. So, without defining a problem, they'll, usually if we skip this, then we will definitely have problem at the following steps. Once we have that, we have to acquire and process the data. So how do we acquire the data? Really, whether it's time series data, whether it's a data from your backbone system, CRM, essentially you have to have the data so that you can have the understanding of the business. And based on that, you, of course, will try to address the problem that you try to solve it. Once you have those two, you start designing the architecture. So since we are in Azure, these parts are essentially important. Why? Because you have to define the environment. If you want to scale, then the pipelines, for instance, are important, and also the variables. So all this will make, differences at the end, and the outlook of your machine learning solution. So this architecture is quite important as well. Then once you go in that, you start training the model. So the training the model is usually repetitive task. So there is always a second bubble to that. So let's say that you try to, have a simple formula for your algorithm. So you have your y variable, and you try to explain it with different sets of data. So what do? You essentially initialize your problem and select the ML algorithm, and then you try to sort of feed it with a batch of data. We call it, sort of training. And then you create a function, whether it's a loss function or any other function, where you say, how I'm gonna calculate, the quality of my model. Of course, then you want to minimize this loss. So this is, again, the second part to that. You calculate how good is the model, and of course, you want to improve it. So this is, again, all iterative. So you keep doing that, you do that, you do that. So every single time you also, let's say, update the weights. In this case, a weight can be, in this formula, W. It can be anything else. It can be multiple weights. So you essentially continue and continue and continue. Once you are done, you start testing your model. So this is, again, you have your model trained, and there are quite a lot of different functions available in Python SDK. So you don't want to overtrain it. You don't want to undertrain it. You just want to have it, somewhere, where it still fits. And once the model comes out, of course, you want to test it against the test data set. And based on that, you evaluate the model, or, with some techniques, how good the model essentially is. And once you're done with that, you deploy the model. And once you have the model deployed, you can go with, several different steps. This is, if you're, let's say, low code kind of guy where you want to, do everything by yourself. With the Python SDK, what also brings on the table is automated machine learning. So AutoML is a technique where essentially you create a experiment. You say, this is my data set. I want to create experiment, and you leave everything on the table for this automated machine learning to do all these processes for you, which means that it basically selects, different algorithms and start, feeding the data in and trying to find the best algorithm there is. Of course, once you do that, you can, once you have the trained model, you register the model, you score the file, whether it's a, your notebook or, in editor. And of course, you want to sort of create an image where you can then deploy the image and also monitor your model. So if you're, coming from an enterprise, every single day in any given enterprise, if you are doing any type of machine learning models, you would have new models coming in. And it's essentially very important, the last part as well, to monitor, how your model is performing. So every given time that, there is a bulk of new data, of course, you want to test the new data as well, whether your model is still performing within the limits of your, accuracy thresholds. So a sense, if it's, on the edge, or if it's out of those thresholds, of course, then you would need to go and retrain the model. So essentially, your problem is defined, so you don't need anything extra. You can process the data, but then you want to retrain the model, especially feeding different features, feeding different data, and you then push everything to train model, you register, and you create an image, and you deploy it. So this is what basically AutoML has given you out of the box, if you want to say. And once we start talking about these repetitive tasks, it is quite time consuming. So let's say you have a data set and you have a training algorithm, let's call it algorithm 1, and you always try to do the hyperparameter tuning. So you sort of create let's say a configuration for my algorithm, and you get your model one. But what if, then I start, doing some other, configuration of my parameters, and I trained everything with these new parameters, and I get the model 2 out. So again, you can see, this is kind of repetitive, and this is only for one algorithm. So whenever I create and take new algorithm, I have to go through all this cycle again, to calculate the loss function, optimize my loss function, then update the weights, change the parameters, and then continue on and on. So this again is quite repetitive and manual work. So we essentially, if we have quite, let's say, a lot of data or quite a lot of models, we essentially want to do this once, so that we save on, let's say, time, on people, and leave everything to the, let's say, automated machine learning to do everything for you. So there are as well some optimization metrics available, and with automated machine learning, it's beautiful because you have quite a lot of different algorithms that are, that have essentially the same metrics that you can then compare. So this is how automated machine learning is capable of doing. And again, it's accessible, it's fairly easy, and it's, less code than if you would go with your normal way. So this is again something that Python SDK also supports. And also there is a, drop click type of navigation in automated machine learning, in Azure ML Service, that essentially you can also just click it and you are good to go. So what does this bring to the table? Yes, we define the problem, we have our input data, and we start applying the constraints. And this is something that you basically just leave on the table, and automated machine learning tries to find the best algorithm for you. And it says, okay, this is the best model. And then what you can do is you can export this model, and that's it. So, just remember that Python SDK has quite a lot of pre-built or pre-installed algorithms. Then there is this Microsoft ML package also available, and then this is automated ML that gives you this capability as well. Once you are done with that, you can always track the thresholds, the running time for each execution, for each experiment. You can also check, how better or how improved a particular run was within one experiment. So the functionalities are there for you to just consume and work with that. And also you can get all the details for every single runtime. Again, these print screens are, you can sort of create them using code, or you have those available out of the box by just, clicking through the navigation of this UI in Azure ML Service. So you, again, can check, various different parameters, how good my model was. Also, you have different metrics available. Again, especially if you are dealing with different type of data sets or different problems, you might want to check different metrics. So, since there was this book that will be available in the raffle, and sometimes you want to, we are talking about now time series data, and you want to see how good your prediction on time series data is. Sometimes you can take, for instance, MAPE, or you just want to go with MAE. So two different metrics, which essentially means that you have to understand, why you would want to pick one over the other one. Or you can go even a step further, and instead of taking MAPE, you can, take, or MAE, you can take median A. So again, all these matrix will give you a particular different output. So if I would be taking median instead of, let's say, average, this would again also sort of have the outliers not being affected, because let's say that we are calculating an average value, and you have a couple of outliers, and those outliers will definitely affect the average score. If you take, for instance, the median, where all the points are sort of being collected or essentially forming, and you take, what is the average of those, or just sort of create and put this in calculation of MAE or MAPE, again, you are sort of cutting off those outliers. So again, this is something that you certainly need to be aware of once you have all the matrix available. And as I said, since this is Python SDK, and also, simply just using Python, whether it's pandas or NumPy, you can do all the calculations there as well. Okay, the problem with automated ML is that it is essentially a black box. So you sort of, open your Jupyter, do all the wrangling and data preparation, you submit it, and you get, this black box thingy, and the result is essentially just some parameters and stuff like that. So you have matrix, and you have your type of algorithm that performed the best. So addressing this and trying to explain why a particular algorithm was better than the other one is also a huge wave that essentially started a couple of years ago, and it's now becoming more and more popular. We can call it interpretability or explainability. With that, it also you also get the ethical AI. So, out of this black box, we will come to a couple of slides later to try to address how to understand, when this automated machine learning gives you, a list of all the best classifiers with given algorithm, and try to understand them. Okay, just a couple of more capabilities. You have, for instance, different ML scenarios that you can just, click or select, whether it's classification, regression, or forecasting. You have beautiful integration. So everything in automated machine learning, in ML services, in Python SDK, you essentially write through notebooks. There are different type of data sets that are, can be fed in. The training compute is quite large, so you can essentially use different virtual machines, dedicated machines, pre-installed machines with different runtimes, different sets of pre-installed libraries. Also GPU if you want to do some deep learning or some image analysis, stuff like that. And also you get all the transparency, and this is through all this Azure Machine Learning Service, and you can easily scale. So those are the pipelines and the cores that you essentially can simply scale much faster. Quite a lot of algorithms are based on those that were essentially created years ago, or developed by Microsoft research team, and they are being added. But then on the other hand, you can also have those imported from different libraries, or even frameworks like H2O, or let's say Onyx, others. So quite a lot of there is already available for you to see and check. Okay, the second part is important, is feature engineering. So feature engineering is something that a lot of data science and machine learning projects are doing, and the feature engineering with the feature store is something that is available for you also out of the box. So with Python SDK, there are quite a lot of functions available that you can sort of perform that. But then again, there is also pipelines that will help you do the feature engineering, or you might call it feature store. So essentially what we are doing is we are trying to find the best feature that would perform with my model the best. And then once we decide, which set of features or input variables, let's keep it simple, will be the best, we can then continue doing that. With that, we can also do, missing values. We can change the missing values. We can do any type of transformations, simply data transformations, check, change anything that might be off. There is also one hot encoder, which is also a function in Python SDK 0.1. Out of the box available, super good. If you want to transform, for instance, your numerical or your nominal variables to any type of categorical feature. Sorry, when you want to change your categorical into numerical, nominal. Sorry, nominal. So one hot encoding is 0.1, for each value in a categorical variable. So all this is available out of the box for you with feature engineering. And you can use it whether it's whether you're using a developer, whether you're using Python SDK, whether you're using automated machine learning, all is there available for you. The next best thing is explainability. So with the explainability, let's just try to imagine, what is explainability. So we have a black box model, and this model is performing extremely good. But then you go to your manager, to a boss, management, and you say, okay, we will deploy this model. And somebody asks, okay, but what will be the effect if we have this particular marketing action in place? So let's say that we will roll out this marketing action next week. What will be the effect on our model, and how will this be improved over time with the customers, for instance? And you have your black box model, which essentially you don't really understand, how it's working. And explainability is trying to sort of give you this insight of all the features or all the variables that are fed into the algorithm or into the model, and try to give you sort of an estimate how much of each of the variable is sort of giving you the information for the output. So let's say that I'm taking, so this is an iris data set, and I try to predict whether the iris plant is of a particular species. And I have 4 input variables, and let's say that petal length and petal width are those two that will mostly be telling me the information about the outcome result. So if I with some, let's say with some marketing action or with some outside action, if I infer in petal width, this will definitely have an effect of my output result. If I infer on, let's say, sepal width or sepal length, this might not have that much of effect. So essentially, this is what explainability will give you. We call it sort of, it gives you the local feature importance for your data set, and also also gives you the calculation of the performance and improvements of a particular feature. Okay, so Python SDK is it's not that old, a couple of years old. It was introduced with machine learning services. Currently, we have version 1. There is version 2, which is still in preview, but honestly don't know when it's gonna come out. So you have this SDK, which is a set of sort of development kit or set of functions that enables you build and run machine learning workflows, models in Azure Machine Learning Services. It also gives you all the steps, needed steps of explaining the data, exploring the data, wrangling the data, making the model, everything. Besides, and on top of that, you also have so-called different flows like ML flow or ML ops, sort of to give you the possibilities of monitoring and logging each experiment or sort of just registering particular model once it's trained and tested for future purposes. You know, you can always go back into the history for each experiment. You can see, you know, which experiment was performing better, which was, you know, degrading or improving. Every single experiment will also have all the artifacts available for you. So you can go back in history when I was, you know, running a particular model, and I can get all the artifacts. And artifacts, I mean, you get notebook out of the box, so you can sort of repeat the whole process. But artifacts as well, like a model, like a trained model, a pickled in Python, pickled model, and also data sets, stuff like that. So you can essentially repeat all the steps. There is also deployment available through different, through different machines, whether you want to scale it, whether you just want to have it on one machine. And of course, there are also REST services available for your model consumption. Couple of important namespaces. There are quite a lot of namespaces, but essentially you have workspace, experiment, run, model, data prep, configuration, web services. These are just a couple of those, and I'm not saying these are all. Just keep in mind that, you know, there are different namespaces. Also, within each of the namespace, you might have different functions available where you sort of create an experiment, register the experiment, and then you can also run it. On the right-hand side of the screen, you can see that I can always have, for instance, if I'm using a Visual Studio Code, I can also run everything from my client laptop. So if I don't fancy, I'm just going to switch to, okay, I'm just going to switch to here. So if I don't fancy that part, like notebooks and writing the notebooks here, I can always go and write everything in Visual Studio Code and do all the preps there. So, you know, this is something that keep in mind, that you are not, you know, bound only to write everything here. You can also just simply go to Visual Studio Code or maybe just Jupyter Notebook, Jupyter Lab. Essentially, any of those things will work for you. The only thing that you have to keep in mind is that you will be needing to install, Azure ML and Python SDK. So keep in mind that you are not married to user interface in the web. If you don't fancy it, you can always, do that in your preferred environment. With Visual Studio Code, it's much simpler because you also do all the authentication, multi-factor authentication. If you fancy any other tool, just keep in mind that you have to register with Azure, and then you are free to go. With automated machine learning, the process is essentially the same. So what you do is you create a workspace, you sort of have it connected to a subscription, and then you create a compute cluster, and then you do your automated machine learning, whether through, again, through your a Jupyter notebook or through the UI. And at the end, you deploy the model. So all this code is essentially, if I would be from infrastructure world, I would say infrastructure as code, but essentially it means that every code is repeatable multiple times. So if you want to do, since I mentioned infrastructure as code, you can, for instance, take ARM template or Bicep and have all the services run through that, push everything through, let's say Azure DevOps. And then on top of that, you have your variables for a particular subscription or particular cluster exported through Biceps, and then input it into a notebook, and you can run that as well. So essentially you would be ending up with, let's say, a PowerShell script that would run Bicep, and then that would get the result of a created infrastructure back, and then you would run a, let's say, a Jupyter notebook. So, you can essentially play around with that whatsoever. Or you can decide, I will create an image and deploy it into Kubernetes or into just as a virtual machine, and have a REST there so that I can, consume the results of that. So any given thing is essentially available for you. Okay, since I've already started playing with with Azure Machine Learning Service, I just want to quickly go with you for those who don't know. So what do you need to do is, if you go, you come to your dashboard, you say Azure Machine Learning, and what you need to do is you create a new workspace, and you are ready to go. Once you have this created, you just launch the studio, and the studio is essentially this. On the left-hand side, you will have all the services assets available. And you can, as you can see, you can manage your assets here, and you can manage your compute and data store here. So notebooks is what will be your playground with the data, the models, and everything. And if I click now on this notebook, you can see that every notebook will have a cluster, compute cluster attached to it, a language. So kernel in this sense, it will be, let's say, Python, but it can be anything else as well. For those who are coming from our world, R was deprecated as SDK, but you can still use it, just a couple of ways around. But I won't go into that because it's we are discussing about Python today. If you click on, let's say you are preparing the notebook, and by the way, I don't know why it's loading now so long. Usually this should be popping up. You can also click here, edit in Visual Studio Code. And if I click this, the Visual Studio Code will pop up. I will have to authenticate it, and bam, I have my Visual Studio Code available for me to start working. So my whole my whole script will pop up here. Every assets, everything will also be available within my Visual Studio Code. I just have to confirm that I have everything, all the multi-factor authentication and everything ready. So you can see that now this is the same as my GUI here. So this one failed to load. Yeah, beautiful. The other one with okay, this is the demo effect. Okay, I'll just repeat that again. Okay, enable public. Wow, this worked half an hour ago. So I don't know why it's not working now, but I will not go investigating. Okay, so as you can see, the whole environment appeared, and this is the same. It could be Visual Studio Code. This has already pre-installed extensions so that I have essentially the same mirror effect. But I can also connect using Python SDK from different user interface. Then I have my automated ML. So if I want to start automated ML, what does this mean? I just create a automated ML job, and I define the asset, whether it's a data set, let's say we go with Ozone, and then you start configuring everything. So type of the experiment, you can create a new experiment, select the existing one, you define the target variable, let's say the temperature, and then you give it a compute cluster or compute instance. And in this case, I'm using the cluster, and you are free to go. Name of experiment, and you define type of the task. So we have classification, regression, time forecast, and those two are essentially in preview. You can also do natural language processing and computer vision. So let's say that we want to do regression. Okay, it's giving me classification. I don't know which variable I selected, but you can go with different based on type of the data, and you select type of validation and type of data assets in case if you have them. And then once you're done with that, you click finish, and everything will be resulted from there on. I will not run this now. Okay. I will go now to Designer. So Designer is essentially the first thing that Microsoft put out. So this is a sample from, I don't know when. So let's say that you have a couple of different data sets and you want to do all your experiment in this Designer. So what does this mean is that I am just drag and dropping different assets into this into the right pane, and every single time I am just defining or editing each particular node, what I want to do with it, and what this particular node is doing. So this is more, exploring easy, absolutely no coding. You then connect the dots, and once you're done, you essentially can run this. What I like about this is it sort of gives you the capability to visualize a little bit more, a little bit better than your standard writing Python code with SDK. So those three are, really up to you how you wanna define, whether it's through the designer, whether you want to do automated ML, or starting, notebook from scratch. The assets are the also the important thing. So you want to have your data, and you can have as much data you want to have, but you can give them different sources. Whether it's, in this case, it's a workspace blob store, it can be Azure SQL database, it can be a file store, Gen2, for instance. essentially anything can be put on here as long as you have linked services and all the authentication on place, then you will be able to use those. So one thing is data. The second thing is the compute. So with the compute instances, you start, working from scratch, and you give your computer name, the location, and then you have GPU or CPU, and based on that, you will have your, category available, whether you want to have memory optimized or for general purposes and stuff like that. And you can also, this demo, okay, something like that. Okay. And then you can also go and do a little bit of extra tuning, and that's basically how you create a just this how you want to create it. And of course, you have compute instances. You also have compute clusters. So clusters is, once if you want to, start scaling, that would definitely work with the clusters. And then you also have inference clusters. So this is once you have your model created, you want to have your data inferred or have new data coming in, and you can then push this through Azure Kubernetes Services or create any REST points. So you can do that as well. Okay, so then there are the pipelines. So the pipelines are like a, standard jobs or portion of the code where you essentially do your, your experiment. But the best part about that is that you can have those pipelines sort of standardized and created in this way that the each section or portion of the pipeline can be reused for later, any other experiment. You also have environments. So this is very good if you are looking for particular runtime. So environment of runtime, essentially the same, but this will give you, some pre-installed frameworks or packages, and also type of the underlying framework and machines that you can use. So this is something that the Microsoft created for you out of the box. You can also track your models. With the models, of course, you also have different, you can check the history of each model, and you can download, as I said, all the artifacts like end model. So this is a model created, and I can download this model and I can use it with any other given Python script. You also have different versions and data, and as well the responsible AI and explanation. So this is something that is still in preview, the explanation and fairness, but what it essentially gives you is capability to start understanding your model. So now that I've come to this explanation, I want to go on how this interpretability and explainability. Okay, so this was taken from GitHub, and you can follow the GitHub. There is a link, but I like it as a quote, because there was a darkness, and then they'll let there be light. So this was the concept behind this interpret ML. Again, everything is written in Python, available for you, and that's it. And what is the difference between when we talk about black box versus glass box? So let's focus on this graph for a couple of seconds. So let's say that x-axis is explainability. the more we go to the right, the better the model can be explained. And y-axis is accuracy. So the further we go up, the more accurate the model is. And this is essentially the line of a couple of different algorithms where you can see, the trade-offs. For instance, if I take support vector machines, it is very accurate, but it is kind of hard to explain. On the other hand, if I take linear regression, it is super easy to explain, but accuracy can degrade over time. So the idea behind those two is, what if we can take the glass box models that are easy to understand, and we can see through the inference how we're gonna get, what kind of results we're gonna get, or we can understand the future set that we put in, versus the black box. The black box, we just fed the data in and we have no idea what will come out. So this is the difference, and just think about it, what we can take from one side to the other side to start working with that. So what is essentially the model interpretability, and why it's important? So we can start asking a couple of questions. Why did my model make this mistake? How can I improve my model? Does my model discriminate? Stuff like that. So all these questions have a sense, a step in this ML project that you can address through. So how can I improve model? Yes, feature engineering, hyper-tuning. How did my model make this? Why did my model make a mistake? Model debugging, quote unquote. But yes, if you do cross-validation, you can sort of find, mistakes like that. And of course, the more we go into the new area, the new world, there are quite a lot of regulatory compliances, or we can work with high-risk environments, high-risk applications, and also so-called human-AI cooperation. Can I really understand and trust a particular given model? So this is what actually the interpretability is trying to address. And again, as I said, I've been in many situations where I've seen, or I've been asked directly, can we trust this model? Or can you explain the results to me? Or what will happen if I, change one input variable? So all these are addressing essentially the same thing. So can I understand? Can I relate? Can I, trust? So this explainability is something that will definitely help you have the better understanding of the model. And as I said, it is emerging branch. Quite a lot of topics are now, generating around this topic. Talks, even services, even Python. Within Python SDK, you have namespaces for that as well. And what are the benefits for a particular business? Of course, you have better decision, you have better control, you have better safety. You can build trust with, as I said, stakeholders, your boss, your management. You can monitor any ethical issues that might be a problem. Of course, you can also address any type of GDPR scenarios and have better results out of that. And what is the difference, or where are those interpretability and ethical AI? So, we should all be sort of having, said or confirmed to that, transparency is a thing. So AI results should be understandable, fairness. AI should treat all, people or all animals fairly or the same, inclusiveness, and then also accountability and privacy. So, this is going from interpretable slowly to ethical. There are quite a lot of stories around surrounding image recognition, and the infamous one where a person was detected. So there was a gorilla. No, so there was a person on an image, and the model detected it as I think it was like a gorilla or something, or an ape. Again, this is absolutely not fair, and yeah, those things should as well be addressed. Okay, but what type of problems can we address? Again, as previously said, interpretability and accuracy. So those are the ones that we are essentially addressing. How do we go about? So the concept was that let's try to understand this issue by defining global and local interpretation. So global interpretation means that a predictive model is mapping from an input space to an output space. And interpretation algorithms in this case are divided into those that are that offer statistics and metrics, let's say, on a region of a domain, and can have distributed features, or joint distribution to the entire training set. So we are taking essentially attributes or any type of distinctions from a single point globally. And in ideal situation, in ideal scenario, there would definitely exist some representation that will allow a human to sort of interpret or make a decision function for any given dimension that we try to interpret. And that's why we call this global interpretation algorithms, because they can either aggregate or subset the features that are available for a particular model. With the local, you can achieve this in two ways. So firstly, you can possibly approximate the behavior. So this approximation of behavior, let's say of a complex number or a complex function, which is in the vicinity of a single input, can be used sort of to simply interpret auxiliary or surrogate numbers or models, let's say linear regression. Or the second way would be to use the Bayes estimator to understand the behavior of a single prediction. Again, by using some type of approximation based on the inputs and outputs. So this is the concept that was developed in between when they, there is even an article on that when they said that, how we can address this issue of having better understandability or interpretability. And the key word was, again, approximation around auxiliary data or auxiliary points that we can sort of stretch it to the next level. And this can be seen, just a second. Yeah, this can be seen right here. So this is line, for instance, and we can see how a particular point on this curve can be sort of approximated further on. And with that, again, we can achieve local understanding of the features that might follow. So whether we are using regression or whether we are using, in this case, classification. Okay, so I went a little bit too far. Okay, so in ML, Azure Machine Learning Services, we have a couple of different features available, functions available. So one, whether we are having tabular data, text data, or image data. And we have, using tabular data, we have SHAP, we have LIME, we have feature permutation, and Mimic, and SHAP can also work with text or image data. So these are, again, available there out of the box. in a sense, how does this work is it sort of explains to you, and these are, again, print screens taken from Azure ML, that sort of gives you which particular variable might have an impact or might have better interpretability if you include it or if you exclude it, or what would happen if you can sort of add some additional information to that variable. And there is also Azure ML Interpret available within SDK, sort of to give you this black box understanding. As I said, supported functions, techniques. So we have probably the most famous one is Lime. The second one is Shep. So there is a original article available, and there's the link. So the Lime stands for Local Interpretable Model Agnostic Exemplation. And the idea is so that you start sort of permuting. So you have your data and you start permuting the data. Once you do that, you calculate distances between different permutations, whether it's original data or fake data. So the one that we try to extrapolate. And then you make a decision, a prediction on a new data set by using this new model, let's say model 2 or whatever. And then you select, again, several different features from that, and you sort of create a new model, and based on those new models, you try to permute the data again. And you sort of reiterate this step over and over again to find a model that would fit all the permuted data within, selected number of features that will still have similar scores or weights. So let's say that I try to understand, how men in my age, whatever, do sports, for instance, and I can say if I'm, let's say, 40, I can take somebody who's 41 or 39, and I can also check, what are their sports behavior. And I will not, degrade a model. I will sort of create 2 additional endpoints and try to sort of do the extrapolation or sort of have, create a new model, try to explain this with new features. So Lime is, as I said, the most probably popular one. And you can, again, as I said, for each individual instance, you can pass the model for each predictions, and it will always sort of like perform with this local sensitivity analysis. You can also use Lime for sort of like classification, and you can see, this is again an example, how accurate would a particular model be. The next one is Shep, and Shep came from originally from this game theory approaches to try to explain the output of any machine learning machine. And what it does, it try to sort of find the optimal, let's say, credit allocated for each, again, local explanation using this Shapley values from game theory. So what does this essentially mean is, let's say you have a model and you try to see based on age, sex, body mass, which of those sort of have the most effect on my output or my outcome. And you can see in this case, it can be age, and then sex, and the other 2 are, just, contributing very little. In this case, the order is very, very important, how you feed the data in and how you interpret. So again, this is something that is very important. The beautiful visualization can also be done with Shapley, and this is again something that you can also do with in Azure Machine Learning services. Okay, there are a couple of more slides here, which I will definitely just skip. And then there is a partial dependency plot, just to have notion of it. And then there is explainability itself. As we've seen, you go with each model and you can check the explainability, and you would have, again, out of the box graphics available for you. So essentially quite a lot for global explanations, and then there is also the local explanation where you can see and understand, try to understand a individual prediction. So how would you go about that is simply, once you have your model, and we've seen it before, you can check the fairness, check the explainability, click on that, and you will get all these results out. Okay, since we are slowly running out of time, I've shown the components, I've shown the interoperability in Azure. The data is available on GitHub, so feel free to have any questions right now. Unmute yourself. Otherwise, thanks for today, and have a beautiful afternoon or evening.
Well, Tomaž, thankfully or sadly, either way you look at it, we have not had any chats, any questions, comments, anything, except for everything that Sarah has put in there, because she has, as always, put in lots and lots of goodness in there for people to look through.
Oh, awesome. Okay, I see now the chat window. Yeah, beautiful. Thank you, Sarah. Okay, so yeah, if you want to get in touch, feel free to drop an email. I didn't want to go too far with the code today because sometimes it's just good to know what capabilities the tooling does. But if you want to go deep dive into the code, feel free, let me know, and we can start writing the Python together. Okay, so thanks everybody.